Okay, hi. Let's look at the problem number 4, assignment number 2, and it's about a convolution. I'll give you some of the hints that how I approach this problem here. Okay. So first of all, as mentioned in the class, I'm reordering the name of the function. So basically, I'm going to call the triangular functions f of t, but the rectangular box as g of t. And of course, the first step is to reflect, and the next step is to shift. So I'll save myself a little bit writing here. And after the reflect and shift, you will have this is your f of tau, and the red color one is going to be our reflect and shifted function g of t minus tau. The edges or the coordinates of the two edges here, this is -1 plus t, and this is 1 plus t. Okay, so now we have these two putting together in one graph, and so let's take a look at how do we proceed from here. Both of them are piecewise functions. Now bear in mind, for piecewise functions, so let me tell you, you probably want to in the future keep asking yourself this question here: what are the critical edges here? Okay. So for example here, for this function g minus negative tau, and I have two edges, and the edges number 1 is tau equal to -1 plus t, and for edges number 2 is tau equals to 1 plus t. And for function f of tau, and we also have two edges actually. The edge number 1 is tau equal to 0, and the edge number 2 is tau equal to 3. Okay? Now these four edges will eventually determine how they overlap and where they overlap. Okay? So let's take a look at this one here. As first question is let's see at what value of t, or how much value of t, how much is shifting for t to have this overlap occurs or occurring. Well, you look at the original function. Apparently, if I move this box here, okay, not only you move to the right, but also if you move to the left, you still have a little bit overlap here. Well, the overlap will not occur only when the edge tau equal to 1 plus t is on the left side of the edge tau equal to 0, and that's when you don't have overlap. Okay, so in other words, okay, the overlap occurs when tau equal to this edge here, okay, or let's just put it 1 plus t, and when this edge is on the right side of edge tau equal to 0. In other words, you want this edge to be greater than 0. So you get t is greater than -1. So as long as you have a value of t greater than -1 and you shift that much of value, you will have overlap between these two functions. So that's the starting point. So in other words, actually, if you let t less than -1, so the convolution, no overlap, that means the convolution between the two functions are 0. Okay, is 0. So overlap occurs when this one here. Now, if I draw my box here, okay, which means the edge, -1 plus t is on the left side of tau equal to 0. So here's tau equal to 0. And this actually gives us the pattern number 1. So I'm shifting this box to the right. Okay, but I'm not shifting my box totally to the right. I'm keeping the edge tau equal to -1 plus t on the left side of tau equal to 1. So when -1 plus t is on the left side of tau equal to 1, then you have -1 plus t is less than 0. And that give you t is less than 1. Okay. Then between this tau greater than -1 and less than 1, well, let's take a look at the region of overlap. Now the region of overlap apparently is this highlighted region. This is the highlighted region. And for this region, if you look at this region here, what's the range for the tau value? Right, the range for the tau value. The range for the tau value, or the range for the region, essentially is going to be the integral limit. In this case here, look at that, it's pretty obvious. It's for tau is between 0 and 1 plus t. Okay. So there you go. This is basically your pattern number 1 region, okay, or pattern number 1 for the convolution. And let's do the convolution here. Convolution is f of t convolute g of t. And as we just found out, the range of the tau is between 0 and 1 plus t. And that's when your shifted value t is between -1 and 1. So between this region, okay, within this region, 0 and 1 plus t, the value of g of t minus tau is 1. The value of f of tau is this straight line. Now this straight line is pretty easy to formulate. It essentially is 1/3 of tau, right? 1/3 of tau. So the integral right here will become 1/3 of tau, which is f of tau, multiplied by g of t minus tau, which is 1 at here, okay, and d tau. Okay. So you do this integral, and it's pretty easy. It's 1/6 tau square, okay, and goes from 0 to 1 plus t. And the value out of here is, of course, is 1/6 1 plus t to the power square. And don't forget, this is for value of t between -1 and less than 1. So I just obtained the convolution for pattern number 1. So let's keep shifting. So drag this box over to the right side. Now if I drag this box now to this location here, so what happened? What happening is I am moving my edge, okay, tau equal to -1 plus t. So I'm moving this edge here to here. So this is -1 plus t, and this is still 1 plus t here. So moving this edge over here. So this -1 plus t now is on the right side of this tau equal to 0 edges. If -1 plus t is on the right side, that means -1 plus t becomes greater than 0, which means my t value is greater than 1 now. And that's a continuation of the previous value here. At the same time, if you observe the same time, I'm going to keep this edge tau equal to 1 plus t, okay, this edge here. On the left side of this edge, tau equal to 3. Okay. So that means I have 1 plus t. This edge is on the left side, so I'll use the cosine here, is less than 3, and which give me t is less than 2. So you combine these two, I have a new range of shifted value for the t, okay, which is between 1 and 2. Now when you shift your box for amount of t within this range, okay, 1 and 2. That means you are placing your box, okay, in this region right here, like that. Okay. Now then the next question, let's take a look at where do these two functions overlap, or what's the region of overlap. And apparently the region overlap is just this box, and the box is like a quick cutter, right? And it's cutting out the triangular functions. Okay, so this is gonna be our pattern number 2. Okay, for this region here, my tau, the range of the tau at here, as you see, the range of the tau is between -1 plus t to 1 plus t. So -1 plus t to 1 plus t. Okay, so this pattern number 2 gave me this integral limit. Now, if I do this integral again, it's from -1 plus t to 1 plus t, and again within this region, right? Within this range is the same thing. The g of t minus tau is still 1, and f of tau is still represented by the function 1 over 3 multiplied by tau. Okay, and the integral only difference is the integral limit. So you put in this guy here, and what I got 1 plus t to the power square minus t minus 1 power square. And you can do the simplification by your own, okay, and that'll be fine. So that's pattern number 2. And for this pattern here, and don't forget, you will shift your t by this much here, okay. Yeah, and this is where you can get this into the convolution for pattern number 2. Well, we're not finished yet. We do have the third pattern at here. Okay. So let's go back to this graph here, and I'm gonna erase the edges coordinates here. Okay. Okay, so let's go back to this row here. Okay, and I'm gonna drag my boxes, keep shifting it. Now let's keep shifting. Watch the edges. I'm gonna shift to this location at here. Okay, to this location. So when I shift this location at here, apparently, let's label this one here. This is -1 plus t, and this is still 1 plus t here. So what's happening is the edge 1 plus t is on the right side of 3, and the edge 1 and the edge 1 -1 plus t is still on the right side of the 3 here. Okay. So let's take a look at the relationship between these two edges, and what does that give us for the value of the shifting value of t. Okay, so first of all, the edge 1 plus t is on the right side of 3, so that means this guy is greater than 3. Okay, when it's greater than 3, I got t is greater than 2. You see, it's a perfect continuation from the previous range of t. But however, this -1 plus t edge, right, is still less than 3. It's still less than 3, and I think I can put a 3 here, and less than or equal than 3. So then t is less than or equal than 4. Okay, so for this region here, for this, I have t greater than 2 but less than 4. And if I do shifting, shift this box by amount of this range, and I can have my box placed in this relationship with respect to the triangular function. So the question in that next question, where is the region of the overlap, right? The region of or the range of overlap. Okay. So you take a look at the function here. Okay. Apparently the overlap is between this portion here. The range of overlap is for tau is between -1 plus t and 3. Okay, so that is my tau value, the range for the tau, or which ultimately is the integral limit. So now my convolution will simply be -1 plus t to 3, and the integrand still the same. It's 1/3, okay, tau, and 1, and d tau. Okay. Then it's 1/3 tau square here to 3. Okay. So you place in the number here, okay, and this is what you get for this much shifting where t is greater than 2 but less than 4. Okay? So that's pattern number 3. Now some people say, okay, do I have pattern number 4? Okay, let's go back to this curve here. Okay, well, talk about pattern number 4. Well, okay, that means you wanted to keep shifting. So what happened to shift? Let's keep going. Well, look, the edge tau equal to -1 plus t. Okay, the edge here. This is edge with -1 plus t, and this is edge 1 plus t. The edge -1 plus t is on the right side of edge tau equal to 3. So that means when tau -1 plus t is on the right side, it's greater than 3, and then tau is greater than 4. And it apparently let's go back here. Apparently, when you look at the two graphs, and the two functions are not overlapping anymore. There's no overlap between the two graphs. Well, this is good. If there's no overlap, that means the product of those two functions is 0. And the product is 0, that means the convolution is 0. So in this case here, when t is greater than 4, the convolution between these two guys is 0. Okay, so there you go. And now I think you obtained every possible convolution for every region or patterns of overlap. Okay, so now we can summarize here. And f of t convoluted g of t. Okay, yeah. First of all, it is 0 when t is less than -1. Okay. And it's let's go back. What do I have for the first pattern here? When t is first pattern is over here. Okay, so when t is greater than -1 but less than 1, I can 1/6 1 plus t squared. Okay, so I got this guy here, and when t is greater than or equal to 0 but less than 1. So the next possible one is when t is greater than but less than 2. And you got a little bit of relative, oops, I'm running out of space here. So I'm just write down the solution first, and then write the range. Okay, so one is here. This is greater than 1 but less than 2. Okay, so that's pattern number 2. And pattern number 3 is when t is greater than 2 but less than 4. And I have the answer for this convolution is 1/6 9 minus t minus 1 squared, like that. Okay, so then when t is greater than 4, your convolution is 0. So that's what you get for this question. Anyway, just take a look at it. If you notice any mistakes, let me know. But the idea is, and here is for piecewise function, being able to tell where the critical edge is. Okay, and also notice the relationship between the two, the critical edges, on which side, on the left or on the right. Okay, basically the edges for this edge here, okay, this edge, and this edge. Okay, so these two edges, they are moving edges. Okay. And when we talk about moving edges, that's basically where you will have the difference of region overlap. Okay, yeah, thanks, bye.